way back at the very beginning of math, you always get this, PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. This tells us how we do math, right? The order in which we do math. If you notice, addition and subtraction have opposites, right? One undoes the other. If I say x plus 3, to get x by itself, I need to do x minus 3. Our addition and our subtraction undo each other. We can go back and forth, right? Then we have multiplication and division. They're paired up also, right? Multiplication and division. 3 times 4 equals 12. 12 divided by 3 equals 4. It's our way that we get to move back and forth. I like to think of it like a seesaw. So 1 gives us 1, we undo it, we go back and forth. It's our way that we can go back and forth. Then they've given you this exponents. Okay, let's not think about that. They give us parentheses. Parentheses just give us a boundary fence. So if you have animals or something, you've got a boundary. Okay, they need to stay in this boundary. We're going to work in this part first, and then we'll work in another. I use it to tell my boys, okay, we are going to, when we clean rooms or we're dealing with the whole house, we're going to clean one room first and take care of it, and then we will move to another room. So parentheses are simply our boundary lines that tell us when we work with these other mathematical processes, okay? Sorry, my brain is tired. So then we have exponents. Why on earth did they leave an exponent all by itself? Because the truth is, it's not really PEMDAS, it's really PERMDAS, which I think is way cooler anyway. So addition and subtraction, they're each other's opposites. Multiplication and division, they're each other's opposites. Exponents and radicals are the opposites. One undoes the other. So if I have 2 times 2 equals 4, I can rewrite this as an exponent, 2 squared, because I have 2 of them, right? 2 squared equals 4. This is still true. I can now undo and say 2 equals the square root of 4, okay? They're the opposites. So just like when we had the multiplication division, if you're doing one of them on one side to get the other answer, you'd have to do the opposite on the other side. Say we have this. I would need to then do x equals 6 minus 3. So see, you've got the opposites, but they're on opposite sides. So if on one side I have an exponent, if I have a radical on the other side, I've got my opposite. Okay? Same things. So what does this little radical thing actually mean? When you have a radical, it gives us this number here. Right here is called an index, okay? The number underneath is called the radicand, kind of like when you're looking, it almost looks like long division, right? But it tells us different things. Our index tells us how many of the numbers underneath we need to have, okay? So when there is no number here, it is an understood 2. Just like when I have x plus 3, the coefficient of x here is an understood 1. I don't always have to write it. If you have the square root symbol with no number here, it is just a 2. You know what? There are cube roots, there are fifth roots, there are seventh roots. You can have any number you want up there. When there's not one, it is understood to be a 2. The 2 tells us what we need, okay? So let's just use our 2 times 2 equals 4. Here, I rewrote my number 4 as 2 squared. So if I had a square root of 4, I could rewrite this as the square root of 2 squared. Okay, you following me? Exact same thing. Now, if I write my index, my understood 2 in here, if I had +1 minus 1, that would give me 0, right? They cancel out. If I have x times 3 divided by 3, these would cancel out and actually give me 1. Okay? The same thing, if I have an index number that matches my exponent number, it erases the whole radical right there. And all I have left is my number 2. So the square root of 4 is equal to 2. Another way to think about that is if we write this out, I really have a 2 there, right? I've got 4. 4 is 2 times 2. If you have chosen not to write it as an exponent, my index number tells me how many I have to have. So if your mom makes cookies and she has 12 cookies, and there are 6 of you guys, or say there's 4 of you, so you and your dad and your brother sit down at the table, and you've got all these cookies, right? 12 cookies. And you're going to divide them out between the 4 of you at the table. You're going to get 3. Your brother's going to get 3. Your mom's going to get 3. Your dad's going to get 3. And when your sister comes over, you'll say, sorry, you're married. Go bake your own cookies, right? So you have subtracted your cookies out. Now, does it make you as a person multiples of those cookies? No. This is just your set of cookies, okay? So I like to think of it in that way, where my index tells me how many I need to be able to remove that set from my main pile, okay? So I need 2 of the exact same. I have 2 of the exact same. So it gets to escape. I like to talk about it like jail. This gets to escape. It does not escape as 2 times 4. Okay, I mean 2 times 2 equals 4. So you're not going to escape it as a 4. You are escaping it as the number that you have 2 of. Okay, I have 2 2s. So that number gets to escape. If I had 2 3s, let's just do this one. Okay, if I had broken it out and I end up with this 3 times 3 times 4 times 4 times 5 times 5. I have 2 3s. So a 3 gets to come out. I have 2 4s. Oh, I should have made those match. So the 4 gets to come out. I have 2 5s. The 5 gets to come out. Okay? When they come out, they are still multiplied together. So now I would simplify back together and say 3 times 20 is 60. Okay? So when we are looking at radicals, this list right here, it says radicals to know. These are ones that you need to have memorized. They will often talk about it in terms of perfect squares. We love to look for perfect squares because if I am working with a square root where I know it's 2, the definition of a perfect square is a number that is squared, right? So that falls into that very first category where when I have 2 and my index matches my exponent, it gets rid of the whole thing and all I have left is the number. So when we have the square root of 9, I can rewrite the square root of 9 as the square root of 3 squared. I know that 9 is a perfect square. It's 3 squared. I need 2. I have 2. Those match. My answer is simply my number 3. Okay. Square root of 25. I can rewrite this as square root of 5 squared. My index and my exponent match. When they match, we get to erase the whole thing. There was nothing left, so I have 5. So perfect squares, square root of 16. 16 is 4 times 4. We can, the other way, 16. We're going to rewrite that. Like on your bonus sheet, it shows the factor tree, 4 times 4. My index says I need 2. I have 2 of the same one, so my answer is the number that I have 2 of. My answer is 4 there. Square root of 49. 49 is 7 times 7. I need 2 matching numbers. I would have 2 matching numbers. That number is 7. Okay, so these are common radicals to know, right? Now, in the same vein, when we have these extra things here. So I said, oh, well, you could have cube roots, you could have 5 roots, you could have 7th roots. Remember, the index tells you how many you need. You get to determine how many you have and whether or not they can get out. So if I have the cube root of 8, let's think about what 8 really is. 8 is 2 times 2 times 2. I need 3. I have 3. It gets to escape. The answer is 2. Now, so what happens when you have more than you need? So let's look at that. Let's look at the square root of 50. My understood number is 2 here. So I am looking for pairs or two numbers that are exactly the same. So I'm going to think about 50. 50 is 2 times 25. 25 is 5 times 5. So if I were to rewrite 50 all together, it would be 2 times 5 times 5. Also 10 times 5. I need 2. Oh, I've got 2. My 5s can escape. So they get to come out. What do I do with this 2? He's stuck. He does not have a buddy to help him get out of jail. So he has to stay. So we would simply write our answer as 5 square roots of 2. There is an understood multiplication sign here. So as you move forward, I'm not sure if you're going to be multiplying radicals, but you need to know that there is an understood multiplication sign here. That is because, remember, x times y times z equals 2. Our commutative property of multiplication says that I can move these around. This is the same as y times x times z, or z times y times x. You know, you can move all of these around because they are multiplied. It is very important to know that when we move a number out front, it is still multiplied times this radical.